Hi there, and today we're going to have a look at how to factorize expressions. So, to start off with, I'm going to give you a question like this, and actually probably a good idea to pause the video and try to design as many expanding questions as you can that give you that as the answer. Now, you shouldn't be watching this unless you've fully understood the expanding work that we have done. So have a go at that and then carry on the video, and we'll see if your ideas or your answers match mine. So here are some of the ones that I've created. So I've said, well, 2 lots of 4xy would give me 8xy, and 2 lots of 6y would give me 12y. So this is an expanding question that has this as its answer. Now if I do, sorry, those lines were just double checking. So I could also take a y out because a y is a common factor to both of them, and by doing that I could get the same answer. Just check. 2y times 4x is 2 times 4 is 8, y times x is xy if we write it in alphabetical order, and 2 times 6 is 12. And I think I've come up with just one more, maybe 2 more. There we go. So here there are 4 different answers. Now, some of you might have gone a bit further and put some negatives in there, or even some decimals. We don't normally use decimals in this type of work, but we definitely do use negatives. So there's actually probably an infinite amount of questions you could come up with. But if you just stick to whole numbers and stick to positives, they are the only 4 that you can really come up with unless you start introducing fractions. Now, what we would say is keep it simple, keep positive numbers on the outside. And you can see I've come up with 4 different answers, and what we actually say is this is the only answer we're interested in. This is what we call it when it's been factorized fully. And it's when we look at the terms and we take out as much as we can outside of this bracket. So we think all the time about designing an expanding question, but only when the highest common factor is on the outside. So yes, these are all factorized, yes, these are all valid expanding questions, but this is the only one that we're looking for when we're asked to factorize something fully, or fully factorize. Take a look at another one. So again, pause the video, try and come up with, I don't know, 2, maybe 4 different expanding questions, and think, have you factorized it fully? Have you taken out as much as you can outside the bracket? Have you taken out the highest common factor of both? So here's my first one. I've got 4m outside because 4 is in the a factor of 20 and 24, and there's an m in both terms, so I can also say that is a factor. I expand that, I get my answer. Here's another one. So I took 2m outside this time, exactly the same process, it works, and just a 4. Now looking at these, so I could have taken out a 2, I just chose to just do 3 for this video. But looking at these, which one of these do you think is the highest common factor and therefore fully factorized? Well, of course it's this one, because it's the highest number I can take out and a letter as well. So we'd say this is factorized fully. So let's look at that in a little bit more detail and a little bit slower. Rather than designing expanding questions and loads of them, let's get there in one step. So the first thing we're going to do is look at just the numbers and say, right, what is the highest common factor? So of course 5 is the answer there, and then we're going to look at the terms to see if there's any letters in both, and because there's a y, I know I can take a y outside because it's a common factor. So I'm going to take a 5 and a y outside of my brackets, and then I'm going to worry about what do I multiply this by to get my first term. Well, just an x. It's kind of like as well, what's missing? So there's an x, so I need an x. Now here, what do I multiply the 5 by to make 15? Well, that's a positive 3 because it's a positive 15. And I've already got the y, so I don't need anything else. So that one's done. And just check all the time by expanding, it works. Let's have a look at this one. Now, I can't look at the numbers because, well, this is a 1x squared, but we never take a 1 outside because it's a common factor of everything, so it's pointless. So I'm only going to be able to look at the letters. So there's a letter common, so we can say a letter x is a common term to both. So I can take out an x. Now, again, think of expanding. What am I multiplying x by to make x squared? Well, that's an x. Now, what am I multiplying x by to make a negative 6x? Well, negative 6, of course. Check it. That works. And that would give me minus 6x. So it's done. So this part here is the answer. Now, we can look at the numbers. We can see that 5 is a common factor. And in the letters, there's nothing common. So all I can take outside is a 5. What do I need to multiply this by to make 15m? 3m's. And what do I need to multiply to make a positive 20m? Well, positive 4, make the 20, chuck the n on, and we're done. So that's the answer. Again, always check by expanding. It gives you the question you started with. You know you are right. Now, this one looks a little bit harder. It is. It's got 3 terms. So, I know that if I look at those, 3 is a factor. Each of those 3 numbers are in the 3 times table. And there is an r in both, so I can also take, there's an r in all of them, so I can take an r outside because that is also a common factor. So 3r. I'm multiplying the 3 by 2 to make 6, and what's missing? An s. R times an s is rs. Now, negative 15. So 3 times negative 5 will be negative 15. And an r times an r would give me r squared. Now 3 times what would give me a positive 12? Well, that would be a positive 4. And if you look here, I've got an r. What's missing is the p. Or r times p is rp. And there we have it. Just again expand it, make sure it works, then you know you've got all the marks. Okay, so that's it for this video, and I suggest you go away and practice some of these and make sure you can get them right, and the next one we'll start to look at double bracket factorising.